this video we have the trig integral of 8 sine squared of x over 8 sine squared of x plus 1. So I'm going to start on this one, and I did look at this for a while, and I've done this little trick quite a few times. I'm going to add 1 to the numerator here of the integrand and subtract 1. So I haven't changed it. 1 minus 1 is 0. And then this will be broken up into two integrals. So the first integral is going to be this part here, 8 sine squared of x plus 1 over 8 sine squared of x plus 1. So in other words, it's going to cancel out. So this will be 1. This quantity over this quantity is 1. And we're integrating with respect to x. So it's dx. Then the second integral will be the minus 1 over the denominator. Put the minus out in front here, and this will be just 1. And I got dx over the same denominator, 8 sine squared of x plus 1. And then I'm going to divide the numerator by cosine squared of x. And of course, that's only legal if I divide the denominator by the same thing. Just like multiplying the numerator and denominator by the same number, same quantity, you just multiply by 1. Now the first integral, very easy to integrate with respect to x, it's just 1. Integrating with respect to x, of course, it's going to be x. You've got a minus here, and then 1 divided by cosine squared in the numerator. Because cosine and secant are reciprocals, 1 over cosine squared in the numerator can be written as secant squared of x. And the denominator, divide the first term, 8 sine squared of x, divided by cosine squared of x. Well, sine squared over cosine squared, that's tangent. So this can be written then as 8 tangent squared of x. And then 1 divided by cosine squared, again, this is secant squared of x. So again, numerator divided by cosine squared generates secant squared here. Still got the dx up here. And the first term here, 8 sine squared of x divided by cosine squared of x, gives me 8 tangent squared of x. 1 again divided by cosine squared, just like in the numerator, gives me secant squared. And this secant squared right here, have an identity that secant squared of x is the same thing as 1 plus tangent squared. So this is replaced by 1 plus tangent squared of x. So I'll simply add this tangent squared to this 8 tangent squared of x. That'll give me 9. Let's change that to a 9. And I'm left with this 1 here. Secant squared of x gets replaced by 1 plus tangent squared of x. Add the tangent squared to the 8, we get 9. We left a 1 with 1 here. So this is plus 1. And then all of that was done using this method simply to get this tangent here. We know the derivative tangent is secant squared. So what we're going to do here then, u substitution here. We're going to let u equal 2 tangent of x. Then du, derivative tangent, is secant squared of x dx. Now, secant squared dx here in the numerator, secant squared of x dx right here, can be replaced by du. So this will become du. So I'm just going to clear it and replace it by du. So we got du over 9 tangent squared of x plus 1. And now this 9 tangent squared of x, I can write this as 3 tangent of x quantity squared plus 1. So that is replaced by this here. Here in the denominator then, so what we have now in the numerator is du. Denominator we have the 9 tangent squared, but tangent is u. So this will be u squared plus 1. And this 9u squared can be written as 3u quantity squared plus 1. So that's what we have in the denominator. Got the du on top, and then 3u squared plus 1. And then we're going in with another substitution. Change the variable now, so let's go to t. We'll let t equal to 3u. Then dt, derivative of 3u with respect to u is 1, or is 3 rather. This is du. So the du then, divided by 3 here. The du then will be replaced by dt over 3. So let's make this a dt then, over 3. I just put the 1/3 out in front here. And this thing can be written then as 3u is t. So this will be t squared plus 1. And now you have this particular formula here that I've used several times on different videos. Anytime you have an integral of the form, or you can write in this form, say du, you can write it as u squared plus a squared, where a is a constant, u is a function, could be a function of another variable, t, u. Anything in this form will give you the integral of 1 over a of arctangent, or tangent inverse, your choice, of whatever u is over a. And then plus the constant of integration. So this then will be x minus the 1/3. And we have it in this form, except instead of a u and a squared here, it's dt t squared, and then the 1 would be the a, because this is the same thing. 1 squared, same thing as 1. So according to this formula, this would be the value of this particular integral would be, of course, the minus 1/3 constant, and then its arctangent. Now in this case, the u is t. But what is t? So this would be t over a, with the a here would be 1. So that would just be t. But what is t? Well, right here. T is 3u. But what is u? That was an earlier substitution, right? U was tangent. Always have to go back to the original variable, tangent of x. And that's over 1, which would just give us 3 tangent of x. So the first integral, of course, was x. That was pretty straightforward. We did a couple of substitutions for the second one, and finally we get the final answer here. X minus 1/3 arctangent of 3 tangent of x plus the constant of integration. That's your final answer. Thanks for watching. We'll see you next time.